Hi, my name is Hellmuth Witte. I'm a design engineer in the Power Products Group here at Linear Technology. I'm going to talk about the LTC3886, a new high-voltage, dual-channel, current-mode architecture step-down controller with digital power system management. This is Linear Technology's first PSM controller that can regulate the intermediate bus voltage in servers and support industrial applications. The PMBus I2C compliant serial interface enables telemetry readback of the input voltage, input current, output voltage, output current, temperature, and faults. Output voltage, current limit, digital soft start, stop, sequencing, margining, overvoltage, undervoltage, PWM switching frequency, and control loop compensation are all digitally programmable. The LTC3886 supports PolyPhase current sharing for up to 6 phases and PWM switching frequencies of 100 kHz to 750 kHz. N-channel MOSFET gate drivers are integrated. Both outputs have independent power good indicators and fault functions. The LTC3886 has an integrated 16-bit ADC and 12-bit DACs, and the output voltage error is less than plus minus 0.5% over temperature. The efficiency of a step-down controller is the output power divided by the input power. The output power is the output voltage multiplied by the output current, and the input power is the input voltage multiplied by the input current. All of these parameters are accurately measured by the LTC3886, allowing the user to optimize the system with no external instrumentation. This makes it possible to optimize efficiency for any given load. The LTC3886 has a wide input voltage range of 4.5 volts to 60 volts and an output voltage range of 0.5 volts to 13.8 volts. This makes the LTC3886 an ideal choice for efficiently regulating a high voltage input supply down to an intermediate bus voltage. This voltage is then used to power downstream point of load converters. Here is a distributed power system. The LTC3886 demonstration circuit is connected to a 48 volt input, and its output is programmed from 9 volts to 13 volts. An LTM4676 8-phase demonstration circuit is used as a point of load converter, which is powered from the 9 volt to 13 volt output of the LTC3886. The output of the LTM4676 is programmed to 1.8 volts. A 0 amp to 100 amp programmable current load is connected to the LTM4676 output. Linear's Linduino One demonstration board calculates the efficiency of the system by obtaining accurate voltage and current measurements from the LTC3886 and LTM4676 via the PMBus interface. The efficiency is calculated at various programmed intermediate bus voltages. This data is then used by the Linduino One to optimize the intermediate bus voltage to obtain the highest efficiency possible. Our LT PowerPlay software displays the efficiency of the LTC3886. The LT PowerPlay GUI can be used to monitor voltage, current, temperature, and fault status. The efficiency of the LTC3886 and the total system efficiency versus an intermediate bus voltage of 6 volts to 13 volts are shown here. The curves represent load currents of 10 amps, 20 amps, 40 amps, 80 amps, and 100 amps. As you can see, the most efficient intermediate bus voltage changes with respect to the load current. Higher load currents require a higher intermediate bus voltage to operate at peak efficiency. However, setting the intermediate bus voltage too high degrades the efficiency of the system at lower load currents. Compared to a fixed 12-volt intermediate bus voltage, optimizing the intermediate bus voltage with the LTC3886, an efficiency gain of 6.2% at 10 amps of load current can be achieved. At 20 amps of load current, an efficiency gain of 3.5% can be achieved. And at a load current of 40 amps, the efficiency gain is 1%. In summary, the LTC3886 is a high-voltage, dual-output, step-down controller with digital power system management. An output voltage measurement error of less than plus minus 0.5% over temperature enables accurate power system monitoring and efficiency optimization. The LTC3886 is supported by the LT PowerPlay software development tool and graphical user interface. Please visit linear.com for more information. Thank you.